All right, let's take some notes on simplifying radicals. Let's break down what this radical means. So this radical symbol means that we are taking the positive square root of a number. So if we consider 25, this means the positive square root of 25. So to find it, you ask yourself, what positive number times itself equals 25? Well, we should know that 25 is a perfect square. 5 times 5 is 25. The next 5 examples are also examples of perfect squares. The square root of 49 is 7, the square root of 100 is 10, and so on. You're going to need to memorize these perfect squares to help you through this. So let's break down each part next. A radical is any quantity that is with a radical symbol. So this is a radical, okay, a little bit of a radical expression. The outside number is still called a coefficient, just like when we were talking about coefficients being the number in front of the variable. That coefficient is still out front. Okay. We have a radical symbol, which I like to call the house. Okay. And 10 is called a radicand, okay, that number inside the house. A radical expression is any expression that contains a radical. The goal of this entire unit is to learn how to simplify radicals. To simplify radicals means to perform every operation possible and make the radicand as small as possible. So when we simplify on Monday, we're trying to make this number underneath the house as small as possible. Okay? No perfect things can be inside of that house. So there's a couple different methods that we can use to do this. The first one is the product property of radicals. Remember, the product property is when something gets multiplied together. So we have the square root of a times b, and we can split that up as the square root of a times the square root of b. And they broke down 2 examples for you there. Okay. So our goal is to look for perfect squares. Okay. So once again, our goal in simplifying radicals is to make the radicand as small as possible. So you can break your radicand up. The square root of 4 times the square root of 3. Well, the square root of 4 is perfect. We know 2 times 2 gets you 4. So that perfect thing always comes outside of the house. So the square root or perfect number comes outside. There are no 2 numbers that multiply to get 3, so we're going to keep that inside of the house, and that is our final answer. Okay? Well, you might ask, well, why couldn't we use 6 and 2? Okay? Well, let's look at the next part of these notes. The simplification was made possible because we knew a perfect square. Divided evenly into the radicand 12. If a person wrote 6 times 2, then no simplifying could be done because 6 and 2 are not perfect squares. There are no 2 of the same numbers that multiply to get 6, and there's no 2 of the same numbers that multiply to get 2. Okay? So thus, it is super critical that we choose perfect squares. Well, Ms. Walsh, what if I can't remember all of my perfect squares? Well, you do need to memorize them. But the fastest way to know that you have the absolute perfect thing is to start dividing by your prime numbers. Okay? Your prime numbers are things that are just multiplied by 1 in itself. So I started a list off here for you. So for example, I'm going to take my calculator and I'm going to start dividing. I'm going to take 45 and I'm going to divide it by 2. Decimals don't work. So now I'm going to take 45 and divide it by 3. Well, that went in evenly, but is 15 perfect? That answer is no. So I'm going to take 45 and divide it by 5. That gives me 9. 9 is perfect. So I'm going to write here, I like to make it a tree, 9 times 5. Well, what is the square root of 9? It is 3. 3 times 3 gets you 9. So I'm going to write this 3 square roots of 5. And this is your final answer. Remember, your perfect thing came out front, imperfect stays inside the house. Well, let's try 72. So I'm going to take 72 and divide it by my first prime number, 2. Is 36 perfect? Are there two numbers out there that can multiply to get you 36? The answer is yes. This is going to be 36 times 2, The square root of 36 is 6. So our answer is going to be 6 square roots of 2. Again, the perfect thing, that square root gets to come outside of the house. Let's try 42. So we have 42 divided by 2. 21 is not perfect. 42 divided by 3. 14 isn't perfect. 42 divided by 5. Decimals don't count. 42 divided by 6. 7's not going to work. Okay? So 42 has nothing perfect about it. This is as simplified as it can get. I want you to cross out this second method here. We're not going to work on that. We're going to work on just those two. So I want you to try 8, 9, and 10. Can you simplify those radicals?